Hey everyone, Mr. Rainsberg here, and we are doing lesson 112, which is a supplemental lesson that deals with properties of exponents. So these are the product rule, the quotient rule, the negative exponent rule, the power rule, or the zero exponent rule. And we're going to be going through these and reviewing them from Algebra 1 and Algebra 2 and extending them into the pre-calculus level. So on the front page, you'll notice that you have mainly what are the different properties and some examples of those, and we're going to be going through them. So the first one you see is x to the 0 power equals 1, and that is the zero exponent rule. And so now let's look at some examples. What that means is any object, and notice I say the word object, any object raised to the 0 power is 1. So 2 to the 0 is 1. 2 is the object. It's being raised to a power. Now notice negative 3 to the 0, well that's also 1. Negative 3 is an object, and when you take a negative to a power, you have to put it in a parentheses. Trust us on this one. Always put a negative to a power in the parentheses. Now, what about the third one? Which part of that's being raised to the power? Well, the object that's being raised to the power is the 7x squared. So that entire thing becomes the number 1. It becomes a big, giant 1. So really, that's 5 times 1, which is 5. So that's the 0 power. It doesn't mean your answer is 1. It means the object to a 0 power equals 1. And the next rule is the negative exponent rule. And the negative exponent rule does not mean it becomes a negative number. What a negative exponent means, and the basic idea behind it, is that it is on the wrong side of the fraction. That is what the negative exponent means. Is, hey, negative exponent, move it to the other side of the fraction. So if I have 4 to the negative second, that really means that I have 1 over 4 squared, which is 1 over 16. If I have x to the negative 12, well, hey, it's on the wrong side. It needs to be here. So when you move it to the other side, notice the exponent becomes positive now. X to the 12th is on the bottom. But what happens if you have 1 over 3 to the negative second? Well, what happens in that case is it's on the wrong side of the fraction. That 3 to the negative second, well, that 3 to a power needs to be on the other side of the fraction. So really, this becomes 3 squared over 1. I flipped it in a way. I made it so the 3 squared goes on top, and that is 9. Now, what's really interesting is I could do, it is really 1 over 3 squared to make it look really complicated. But remember, when you divide by a fraction, you flip and multiply, and that's what I did here. So if I look at this one, 1 over 5x to the negative fifth, I have to figure out which part is the one being raised to the power. Is the 5 with the x being raised to the power as an entire object? Is it 5x to the negative fifth? Or is it 5 times x to the negative fifth? And in this case, the only part being raised to the negative power is the variable x. So the 1/5 stays, because the 5 is not being raised to a power. But that x to the negative fifth, that negative tells me, hey, x to the fifth is on the wrong side of the fraction. So it's going to be an x to the fifth on the top. And I'm just going to remove the 1 because no one likes writing coefficients of 1. So a negative exponent means move it to the other side of the fraction and the exponent becomes positive. That negative is the moving it to the other side. What about these? And these are rational exponents. You cover this a little bit in Algebra 2. Rational exponents really relate to roots, square roots, cube roots, fourth roots, fifth roots, etc. Now, if we take a look to the side, we can see that there are 2 different ways of looking at it. There's one that goes to powers right away, and there's the other that goes to roots. Notice the roots are written a little bit differently here, and we will take a look at that. If I'm dealing with variables, and I'll have to say write this down, if I have only variables, then this is the format I use. If I'm dealing with just numbers and no variables at all, this is the format I use. Mental math is quicker with this format, and it's a lot easier to simplify with variables with this format. So we're just going to keep that in mind. Is this top one's easier for simplifying with variables, this bottom one is easier for simplifying with numbers. So let's try this out. How do we change 5½ to a root? Well, a 1/2 power, if I take a look at it, it means that I am taking the square root, the bottom is the root, and the top is the power. So square root, we don't put a number in front. So this really means the square root of 5 to the first. The root is a 2, which means square root. The power is 1, 5 to the first power, which we don't ever show first powers. Let's see, 8 to the 2/3 power. Well, if I do this, I can look at it a couple ways. I can do it the long way, which we'll look at this one. Let me do the 8 to the power of 2, because that top one is my power, and the bottom one is my root. So I'm going to do 8 squared, and I'm going to do the cube root of that. I'm going to use that 3 as a cube root. Well, 8 squared is 64. The cube root of 64, it's 4. So I can do that. Now, I don't like doing it that way with numbers because I took 8 and I made it bigger by squaring it. I'll do it the other way on this one. I like to, if I'm doing mental calculations, do them by making the numbers smaller and then raising it to a power, because dealing with smaller numbers is a lot easier. So if I have 16 to the 3/4 power, if I were to use this one, which is the same way I like to do with numbers, you do the base, 16, to 1 over your root. So I'm going to change this to 16 to the 1/4 power, 1 over your root, and then I'm going to cube it. So the 4th root of 16, well, I take the square root of 16, which is 4, and then I square root it again. That's how you can do the 4th root pretty fast. Square root and square root. So that would be 2. Square root of 4 is 2. So 2 cubed, which is 8. So 16 to the 3/4 simplifies into 8. Now, why did I do it this way is I made 16 smaller and then raised it to a power. I could have done 16 cubed inside a 4th root. Those mean the same thing. So that is the same as this. I would still get 8, but I can't take 16 to the 3rd power very easily. But I can take 2 to the 3rd power. And that's why I like to do this with numbers. I say when I'm dealing with numbers, I really like this one because it makes the number smaller before you raise it to a power. And it's easier to do that mentally and not make mistakes. Then you have the product rule, which says if you're multiplying like bases, you add your exponents. So 7 plus 2 is 9. Negative 4, remember if you don't see it, it's a 1. Negative 4 plus 1 is negative 3. But wait a minute. What does that mean? Well, it means answers should be written with positive exponents. You should never have a negative exponent in your answer. So I have to change this. So what negative exponent means, it's on the wrong side of the fraction. So I'm going to change it to 1 over y cubed. And it doesn't have to be variables. If I have 2 cubed times 2 squared, I can just say it's 2 to the 5th, which in this case is a small number, and I can just say it's 32 at that point. I can do 2 to the 5th, it's not too big. It's easier to write it as 32 than it is 2 to the 5th. So that's the product rule. Well, then you have the power rule. Power rule says if you're taking an object that has an exponent inside of it and raising that object to a power, you're going to multiply the 2 exponents together. Because this really means I have 3x squared being multiplied. And rather than writing it out like that, that's just a lot of work. I'm just going to take 3 times 2 and get x to the 6th. It doesn't matter if it's a fraction. 1/2 times 6 is 3. 1/2 times 4 is 2. Ooh, what about this one? Well, I can say, I'm going to put it in there, and it's going to be 3 times 3, so it's going to be 3 to the 9th. Now, 3 to the 9th, don't have that one memorized yet. Someday I will. Not right now. So that one, it's going to be a lot of numbers. It's not worth writing down. I'm just going to leave that as 3 to the 9th. So these are all the rules that you are familiar with from Algebra 2. And we're going to extend these to some more complicated problems, and I will start those next. So now we're looking at the second part of the video, and in this video we have 6 problems. We have the first 4, which deal with variables and coefficients, and then over at the bottom there we have 2 of them that deal with just numbers. And the idea there is to make sure that we can combine first, so we deal with smaller numbers and raise those to powers. So let's just dive into 1 through 4, the ones that deal with variables. And when you're looking at those, the main idea to get is focus on objects. Do not focus on all the individual variables until you start combining and simplifying. So if I look at the first one, that one has a third power. That's the first object I see. The second object way over there you see is the negative second power. So there's two parentheses, and I'm just going to simplify them separately and then combine them into one. So I'm going to focus on this one first. I'm going to focus on the 5 squared b to the negative 4th being raised to the third power. Well, that's my power rule. I'm going to distribute this in to the exponents. So that's going to be a 5 to the 6th and then a b to the negative 12th. And I can still simplify because if I look there, that's a negative exponent, which you're not allowed to have, and I have 5 to the 6th. Now, I don't have a calculator with me, so I'm going to have to figure this out. 5 to the 6th is another way of saying it is 5 cubed squared. I know 5 cubed is 125. And luckily, and I remember I went over this, I know how to square numbers that end in a 5. So it's going to end in a 25, I know that. And 12 is going to be multiplied by one number larger than that, so 12 times 13. That's going to be 156. So 5 to the 6th power is 15,625. There. Didn't need a calculator. And now I have b to the negative 12th. Well, what does that negative mean for the power? That means you have it on the wrong side of the fraction. So I'm going to put it on the bottom, b to the positive 12th. And that's just the first object. I'm going to leave it there, and I'm going to see what happens when I deal with the other object. And so I'll do the other object in green. So in this one, what happens? Again, I'm going to use the power rule. I'm going to distribute, and this will be 3 to the negative 2nd, and then b to the negative 10th. Well, what happens here? Well, both of those are being raised to the negative power. So that means that 3 to the negative 2nd is really 3 squared. That's on the wrong side of the fraction, so I better put it on the bottom here. And so I have 1 over 3 squared, which I might as well just say is 1 over 9, and 1 over b to the 10th. And, well, what happens when you multiply fractions? Well, they just combine together to give you one fraction. You multiply the tops. Anything by 1 is just itself. I have a 9 for a coefficient, and I'm multiplying these, b to the 12th times b to the 10th. Not multiplying the exponents. I'm multiplying b to the 12th times b to the 10th. When you're multiplying like bases, you add the exponents. And so that is your answer, 15,625 over 9 b to the 22nd. Now in this case, you would look to see, can I simplify my coefficients? And I know I can't because my bases had nothing in common. So therefore, their powers are going to have nothing in common. So I can't simplify that anymore. Let's go to number 2. And man, that looks intense. I mean, you see negative exponents. I see a couple x's there and some y's. Do it in parts. Look at the objects. I mean, these are all being multiplied together. So let's just kind of simplify easily. It depends on what you want to do. There's a lot of ways of doing this problem. So I'm looking at it. I'm going, okay, let me just leave it alone first. I'm not going to do anything to this first. X squared to the negative 2nd. I could change that to x to the negative 4th, and hopefully you can see the color coding to help out. The y cubed in z, I'm not going to work out. I'm just going to leave it there. But notice I'm putting some distance in between them. I'm trying to make sure my like variables are together, and I'm trying to separate them because y's can only simplify with y's, z's with z's. The denominator is an x, it's a y to the negative 4th, and it's a z to the 4th. So again, notice vertically I have them aligned in columns. My x's are in one column, my y's in another. It's going to be easier for me to see the simplifying that way. The hardest one, it looks like it's the x. So I'm going to leave that one for the end. The other ones are not bad. If I look at this, and this will be my final answer spot, if I focus on the y's, that y to the negative 4th, I mean, that tells me, that negative 4th tells me it's on the wrong side of the fraction. It should be up there. So really, I would move the y to the 4th to the top, which means I'm going to add. And so this becomes a y to the 7th on the top. What about this one? Well, when I subtract, because I'm doing quotient rule, 1 minus 4 is z to the negative 3rd. Well, that negative means it's on the wrong side of the fraction, so I have to put it down here and make it a positive. So those two are done. But what about this one? Well, if you look at it, it's not simplified yet because I have two x variables on the top there, and I need to make sure I only have one base. So when I'm multiplying like bases, what I'm going to do is I'm going to add the exponents. So this becomes x to the negative 7th over x to the first. In this case, if I simplify it, I'm going to subtract again. I get x to the negative 8th, which means it's on the wrong side of the fraction. And that means I have to put it on the bottom. And so there you have it. The answer is y to the 7th over x to the 8th c cubed. Now this is the mathematical way of doing it, not the Mr. Rainsberg way. The Mr. Rainsberg way is an interesting way. I look at the fraction bar as the equal sign for exponents. Is if you want to move an exponent to the other side of the fraction bar, you do the opposite operation. So what that means is if I have a negative exponent and I want to move it to the other side, I'm going to add it. So when I have, and I'll put it down here, x to the negative 3rd over x to the first, to move this, I move the smaller one, I'm going to do the opposite operation. So I'm going to add it. 1 plus 3 is 4. This was x to the negative 4th on top. We'll combine those a little bit later. I have a y to the negative 3rd. Sorry, y cubed over y to the negative 4th. I don't want to keep the negative 4, so I'm going to move it to the opposite side of the fraction by adding. So that's a y to the 7th on top. I have a z over z to the 4th. This is a positive 1. I'm going to move it down there by subtracting. And that's going to be a 4 minus 1 is 3. And when I combine these, I would move that negative 4 to the bottom by adding. This one's really complicated, and we're going to get there. Just meant to kind of teach you to do it in parts. Let's look at number 3. Now this is up to you. How do you want to deal with this one? You can do properties of exponents on the inside, and you can do the properties of exponents with the parentheses. You can follow order of operations. You can do the exponent first and then simplify. I'm going to do the inside first, and I'm going to use my rule. I'm going to take my 2, and I'm going to spread out the inside first, and I'm going to simplify it. So boom, just so you can kind of see, and I'm going to do the Mr. Rainsberg Rule. The Mr. Rainsberg Rule says to move an object to the other side with the exponents, you do the opposite operation. 2 is going to stay where it's at. Well, if I look, negative 5 is smaller than the negative 2, so I'm going to move this to the other side by doing the opposite operation. So I'm going to add 5. That's going to get rid of that there. Negative 2 plus 5 is x cubed. I have y cubed over y to the 7th, and that means that I'm going to move the smaller one. So I'm going to move this 3 to the other side by doing the opposite. Well, that's a positive 3, so I'm going to subtract, which makes it a minus 3. So that moved, and that's a y to the 4th on the bottom. But I still have that big parentheses there, don't I? So I need to take the 3rd power of this. Well, 2 cubed is 8. I'm going to multiply, and I'm going to get x to the 9th. And I'm going to multiply, and I'm going to get y to the 12th. And that's my answer. So in number 2, it probably was a little bit harder to understand my shortcut because there's so many variables you're combining, and hopefully this was a lot easier to understand, is you do the opposite operation and move it to the other side. And you always move the smaller of them, because it's easier to move less objects than it is more objects. And that's your answer. Let's look at number 4. Now what about this case? Well, in this case, something should be staring you in the face, and that's that negative sign. It's intimidating, especially attached to a fraction. So let's just pause for a second and figure it out. What does a negative exponent mean? It means it's on the wrong side of the fraction. It doesn't mean anything about positive or negative numbers. That negative exponent means it's on the wrong side of the fraction. Well, what's on the wrong side of the fraction? Both the numerator and the denominator. The a to the 6th is on the wrong side of the fraction. So that a to the 6th needs to be put on the bottom. The 27 is on the wrong side of the fraction. So that 27 needs to move to the top. So the first thing I like to do, if I have a negative exponent attached to a fraction, that really means flip the fraction. That's all it really means. Now I'm going to bring it in. I have 27 to the 2/3 power, and I have a to the 6th, and that's also going to be 6. It's going to be multiplied by 2/3. Well, between those two, 6 times 2/3 is not that bad. 6 times 2/3 is going to be 4. So on the bottom, I have 4. But what about 27 to the 2/3? Well, it's a number being raised to a rational exponent. So I'm going to break it down, and I'll do that up here. That's going to be 27 to the 1/3 squared. I'm going to take the cube root of 27, and then I'm going to square it. The cube root of 27 is 3. 3 squared is 9. It was easier for me to take 27 and to break it down to be a smaller number than it would be to me take 27 and square it first, because I don't want to take 27 and square it first. I want to take 27 and make it smaller and then square that number, because it's easy to square 3. It's hard to square 27 and then take the cube root. So when I deal with numbers, I like to deal with the root first and then the power. And do remember, the root is the denominator, the power is the numerator. Cube root, and then I end up taking it to the second power. Those are your variables. Now let's look at numbers, because you're going to face ones like this. Well, those are not the same bases. They're remultiplied, so I can't use my product rule because they have to be the same base for me to use them. So what do? Well, when they're numbers and they're not the same bases, you have to ask yourself, can you make them the same base? Is there a way for me to write 36 as a power of 6? And I like to look at the smaller one. I like 6 squared. Is there a way for me to change 36 to a power of 6? I know 6 squared is 36. So I'm going to replace 36 with 6 squared. I didn't change the numerical value of it. I just wrote it a little bit easier. And that's a negative third power, and I still have this 6 squared out here. Well, let's just leave this 6 squared here, and this is my power rule. I'm going to multiply them. And so I have 6 squared times 6 to the negative 6. Well, now I can add them because they're the same base. So that's 6 to the negative 4. And that is 1 over 6 to the 4th. So in this case, 6 to the 4th is not too bad. That's really 36 squared. Unfortunately, I do not have my calculator on me again, so I have to figure it out. So it's going to be 900, and it's going to be 360, so that's going to be 1260. So I think this is 1296. So 1 over 1296, I believe, is the answer for this one. I hope I am right. We will move on. Now it gets more complicated. It looks worse. I can't combine these. And notice, again, no calculator. I'm just going to try and combine them to make them a little bit easier. Well, the smallest base I see is 5. And it'd be really nice to try and change 25 to a power of 5. And I can. I can write 25 as 5 squared. That would allow me to at least combine that top together, because now they're going to be the same. What about 125? Well, 125, that is 5 cubed. And so that object is being raised to the negative second power. Notice, if I take a look at this, I have all bases of 5 there, which means I'll be able to combine them. I have 5 to the 4th, because I multiply here, times 5 to the negative 3rd, over 5 to the negative 6th, because I'm going to do 3 times negative 2. That'd be 5 to the 1st, over 5 to the negative 6th, which means I'm dealing with the negative exponent. It's on the wrong side. Remember my shortcut? Take the smaller one, move it to the other side by doing the opposite. I'm not going to do any mental calculations there. I'm just going to say the answer is 5 to the 7th. So when you deal with all numbers, you can still use your properties of exponents to help you out, to make it an easier number to work with than trying to go to your calculator. In all seriousness, it's easier to work with 5 to the 7th than it is to actually calculate out the value of 5 to the 7th. So that's where property of exponents come in. So that is your lesson. That is a supplemental lesson for 112. Hopefully you understand it, and you can go ahead and get started on the work.